Hey guys, today we're going to be solving Leet Code question number 17, letter combinations of a phone number. So to start out, what you'll need for pretty much every single solution is a sort of map, because you can't really solve this problem without using some sort of map. So I'll copy and paste that in and then talk about why we need it. Alright, so here's our map, and you can see we have key value pairs that all point to an array, and this will just make our life a whole lot easier. I don't even think the problem would be possible to solve without something of this manner, and it just makes it so that we can call the number 2 and then get the array of subsequent letters that will be on the keypad of a phone number. So the goal of the problem is to get all of the different combinations that could be made from, let's say, when you type in 2 or 3 on a keypad. So you could get AD, AE, AF, all of these ones right here. Alright, so the key things to think about while I type out this first solution is that if you look at all of the solutions, it starts with the first letters from that initial input value. So 2 is ABC. All of the solutions will start with ABC, and you can see even if we go up, all of them start with A, B, C, followed by 3. So the second letters, all of them will be in this third one. And then all of the last ones will be in 6. So see N or M, N, O, O. So they stay in the order pretty much. And another thing to think about is the length of the solution, as you can see right here, or right here, is the length of these arrays multiplied by each other. So the solution 2, 3, the length of the array would be 3 right there, times 3, or the length of this one would be 27, because we have 3 times 3 times 3. So keep that in mind as I type out the solution, and I will talk about it as I go. So this is the frame of the solution. Right here we define final, and we define it either as the first item in the digits. So in this one it would be 2, and we would define final as ABC, just right there. Or if this is a falsy value, so it would come up as undefined, because like in this scenario, we would just return, or in this scenario I meant, we would just have this right there. And then if it's equal to or less than 1, so in these two solutions right there, equal to or less than 1, we would just return final, which would come up as true for both of those. So this, if I run it, these two are already solved. So those are just solving for some edge cases, because in the solution we need to be able to map through final, or make a for loop through final, as you will see as I type more out. Alright, so this is the completed solution, and you can kind of see how the function would flow. So for every single digit, every single one of these, we would loop through, define temp final as an empty array, and then every single item in final, which we would define as temp digits, or as a phone key mapping digits 0. So in this scenario it would be that. So we would define that out as 1, because we have already defined 0 right there. And then for every single one, we would loop through the final.length. So every single item would be A, B, C, and then inside this for loop we call another for loop, which maps through digits I. So I would be 1 in this scenario, so it would be 3, go up to 3, loop through every single one of these, D, E, F, and we would push final H. So it would start out as A, then B, then C, and we would push phone key mapping digits I. So phone key mapping digits I is DEF, and we would loop through that and push J to it. So from this, temp final would become AD, AE, AF, then it would move on to this one, BD, BE, BF, to C, same thing. And finally, after these two for loops, we set final to be temp final. So then in a longer scenario like this 2, 3, 6, we would take our new final array that we made, which would be this 2, 3 array. So we would take this array right here and then loop through and add 6 to every single one. So if you look at the solutions right here, you'll notice that the solutions for 2, 3, 6 are just these, but every single one has M and O stacked onto the end of it. So look, AD, AE, AF. Go over here, AD, AE, AF, just with M and O, M and O, M and O. And that kind of goes back to what I was saying initially with think about how every single one is in order and how every single one starts with the first letter, and you can kind of take that on to the second letter, fourth letter, fifth letter, because if we were to add another one, let's say to this, if we were to have, in this case, 2, 3, 6, 8, and run it, all of these values start with the AD, M, ADM, ADM to ADN, so it's just building upon this one right here with ADM, ADN, and it kind of just splits it up. So I'll submit this, and as you can see, the runtime is not great. That is because we are doing a for loop and a for loop and a for loop, which it's not the best, so I will show a better solution. And we will keep the map because, like I said, it's pretty much essential for a problem like this. And one of the key things to think about while I type out this solution is that the length of the original digits is the length of all of the subsequent substrings that is returned in the output. So you see the length right here is 2, all of these are 2, length of this one is 2, or the length of this one is 1, all of these are then 1. So keep that in mind as I type this out. I'll type it out and talk about it as I go. So here's the frame of the solution that I'll be typing out, and you can see that we're going to be calling this function recursively, and the very first input that we do is an empty string, which will be passed in to that string property, and we start out the index as 0. So I'll fill out this recursive function real quick. Alright, so here is the recursive function, and we have the base case right here, which pushes an item to final. And then here is the recursive call, and it's inside of a for loop. And we call this recursive function for every single item in phone key mapping digits index, which would just be one of these depending on the digit index. So any of those, we call this for loop, which is the helper, and it breaks out of the recursive call eventually because we call it with index plus 1. So I'll run this, and now I'll talk about it and how the data kind of flows through it. So how the flow of data changes from our previous solution is instead of looping through our final array and making a new temporary array pushing the old final to it, if that makes any sense, as we did in our old one, right here we make the entire string, so we make all of that in the helper and push it. So I made a quick Google Sheet to kind of, help explain. So here's solution 1, and in the first iteration of our for loop we would have A, B, C. In the second one we would take that and then make AD, AE, AF, BD, and so on. But with this one, we call the helper function for every single item, and we return the full string outright. So the reason that this second solution is faster is because we aren't rewriting the final and then returning that. We're simply just pushing it. So this final never really gets rewritten. We could set it as const, and it would still work. So that is Leet Code question 17, letter combinations of a phone number. I hope you enjoyed watching. Be sure to like and subscribe, and have a good one.